So then there are two types of cathodic protection. One is by sacrificial anodes and the other is by impressed current. I will talk about sacrificial anodes. So where sacrificial anodes is basically two materials touching together or an electrical contact in between both in the same electrolyte. So we have anode, cathode, electrolyte, and electrical contact. So the science behind cathodic protection is electrochemical series. We reviewed the electrochemical series at the beginning of the year. The cathodic protection intends to make any structure to work as a cathode in any electrochemical cell. So as I described, or as we described at the beginning of the course, when we have the novel material touching the active material tends to have an accelerated degradation to protect the novel material. So a galvanic anode is connected electrically to a submerged structure, produce a net current through the electrolyte to the intended structure to be protected. So if it's a buried pipe or tank of this pipeline in the subsea, if it is a platform that we need to protect, if it's a storage tank that is sitting on the soil, if it is a bridge and we have the rebar, the concrete is the electrolyte, and the humidity plays as an activity, and any material that is in an electrolyte that touch another material that is in electrical contact with another material tends to make a galvanic corrosion. So the principle of the cathodic protection is the galvanic corrosion. This is the galvanic series. As we said, for example, if we have iron, this reaction iron, or this is the reduction reaction, but if we see the cathodic, the oxidation is iron goes to iron 2 plus to iron ions. If this iron is coupled with magnesium, then the magnesium will be on corrosion, so it will be magnesium going to magnesium 2 plus, and the iron will remain as an iron in metal. So if you remember the Purbe diagram, when we talk about iron, we saw that the immunity zone of the Purbe diagram is the minus 850 millivolts. The cathodic protection then, or any sacrificial anode that we couple with iron, should or must deliver a current high enough to polarize iron to the minus 850 millivolts versus the copper sulfate electrode. We review all these concepts were visited and reviewed during the first time, the first part of the course. This is an example when we have zinc and copper. So first we need to identify zinc as the anode and cathode. Then we have copper as the cathode and hydrogen as the anode. And when we couple zinc and copper, basically the anode becomes zinc, so the anode is corroding, and the copper becomes the cathode. So the copper is protected.